Okay, so here we are, guys. Let me share my screen. Good afternoon to everybody. I'm Chris Panugakis. I am a Microsoft certified trainer. Okay, let me share it again. Sorry. Um, I'm going to present to you today a topic that it's hot for many security guys out there. It's about Microsoft Copilot for security. By the way, congratulations to the organizers. I've seen many fantastic sessions yesterday. Uh, I've seen a lot of developer sessions, however, but excuse me, guys, I'm not a developer. So what you're going to see during the session is something a little bit different from the um, developer session. So as I've told you, I'm a Microsoft certified trainer since 1998. I'm an ex MVP and I'm located, as you can see, in Greece. So let's go through the presentation and we're going to see together what Microsoft Copilot for Security is. I'm going to show you a lot of Copilot security exams and demos, but bear with me till the end because I have a really scary security case to show you. Okay, so let's go on. And first, let's do a small introduction about what Microsoft Security Copilot is. So, as Microsoft says, it's a generative AI-powered assistant for security and IT that empowers teams to protect at the speed and scale of artificial intelligence. What you can see from this slide is that Microsoft Security Copilot is integrated in Microsoft Defender, in Microsoft Sentinel, in Microsoft Entra, in Microsoft Intune, in Microsoft Purview Information Protection. Actually, is integrated everywhere when we talk about Microsoft 365 security and Azure. Okay, so the good thing about Microsoft's Copilot security is that you can use it by using the so-called experiences. This is something that Microsoft uses to call these different flavors, let's say, of Security Copilot. The one in the left side, it's the embedded experience. I'm going to show you a lot of examples related to that one, but as you can see, it's the experience that lets you get Copilot guidance natively within Microsoft 365 Security, Defender, Sentinel, Azure, you name it. But of course, another flavor of Security Copilot that you can use is the standalone experience. The standalone experience is a portal by itself that lets you use the so-called prompt books. We are going to see some examples of prompt books also. Okay, so everything is automated here. You can get ideas, you can use real life language to get information about your security incidents and also guidance about what could be the next step to you for you in order to respond to a security incident. Okay, so another thing that we've seen that it actually works now with Security Copilot is that you can use logic apps in Microsoft Azure to build your own logic and better understand what information you get from Security Copilot. I have a lot of examples just like this. We'll see them in a moment. So let me show you a small screenshot of what is the standalone experience. It's a portal that you can actually use prompt books. You can see some examples of prompt books down here. Let's say, for example, we can use that one to do a suspicious script analysis, or you can use this one, this prompt book, to do a Microsoft 365 Defender incident investigation. As you can see, what is actually a prompt book? It's a series of prompts that are already there, and you can run the prompt book and get all the results and all the information you need related to security. So this is the standalone experience. You can actually use type your prompts in natural language and receive responses, even if you don't want to use the ready-made prompt books that are located here. The next experience is the embedded experience. As you can see now, I use the Defender, the 365 Defender portal. And what can I do with this is to click that magic button here, which is present everywhere in Microsoft 365 Defender. In this specific screenshot, as you can see, I need somehow to get a query for the advanced handling in Microsoft 365 Defender. So what I would like to do, I would like to get logon attempts by domain accounts targeted by credential theft. But I need to write a query for this, and I don't know how to write queries. As I told you, I'm not a developer. What can I do? I could ask Copilot to write the script for me. So it will give you the query to get logon attempts by domain accounts targeted by credential theft. You just add and run that query in the advanced handling window here, run it and get all the information that you need. So practically, you don't need to write this query by yourself. You just have Copilot to write it for you. These are some of the things that you can use by using the embedded experience. And let's see some demos. Probably one of the cases that you have to deal very often with security in Defender XDR and even Microsoft Sentinel is to investigate failed login attempts. This is something that happens every day, every single day. Users that forgets their passwords, or maybe a failed login attempt uh, could be, let's say, an attack, a brute force attack or whatever. So let's see what you can do in order to investigate these failed login attempts by using Copilot for security. So for this specific case, I'm going to use the standalone experience, and I'm going to search for a prompt book in the prompt book library. The prompt book that I want to search for is the failed login attempts. And as you can see, there is a prompt book here, which I can actually use. And if you click on that prompt book, you get all the automation steps that this prompt book can give you. Let's take a look at the steps one by one. So the first the first step is to run a query to identify failed sign-in attempts. Okay. And then as soon as Copilot gets this information, we move to the next step. The next step could be to provide a representation of the above results in a JSON format. And let's use the top 5 records of these failed login attempts. The next step could be to run a reputation scoring for the IP addresses identified in that specific login attempts information that we get. The next step is to use Microsoft Defender Threat Intelligence and also run geolocation for the IP addresses identified in that failed login attempt. And finally, create a report with the findings from the About investigation. And you can see how beautifully this prompt will create a report. Consider factors such as sign-in details. This will be included in the report. Association with security groups, IP's reputation scoring, authentication methods, device compliance information, and many other things that will be included in that report. So you just simply run it. It will use the information of all failed login attempts that were detected using Microsoft Defender XDR, and you will get and information like this. The next step that you can do actually is that one. You can create a logic app in the logic app designer in Microsoft Azure. So as you can see, we've created a logic app here. We collect the information about the incident from Microsoft Sentinel, and we run a Copilot security prompt book on that specific information, on that specific incident. Okay, as soon as we can go through this step, then we submit this information for a security prompt in the prompt book, as I showed you before. And finally, with all that information, then the final report that was created, we can use that information to send an email to the security team of our company. And this actual email information could be something like this: an investigation report of anomalous sign-ins, findings, IP addresses, sign-in counts, locations, client application used, IP reputation score, and risk level. So the security team will get all that information generated almost automatically by using Copilot for security. Okay. Another demo that I want to show you is how to get a report that analyzes a suspicious script. Again, we've seen a lot of times that we get suspicious scripts in Microsoft Defender XDR and also in Microsoft Sentinel, but let's see how we can use Microsoft Security Copilot to actually get information about what a suspicious script does. Luckily for us, there is a prompt book ready-made there in the portal, in the Security Copilot portal. This prompt book is called Suspicious Script Analysis, and it has some very specific steps. So the following script was found as part of a potential security incident. The first step will be to explain what the script does step by step and after the intent. Also note any actions expressed that could be malicious in nature. The next step could be to actually use that and provide the reputation of any IP addresses or host names found in the script. The next step will be to list any threat intelligence correlated to indicators found within script, and I'm going to show you some examples of indicators later on, and provide me a brief summary and include links to source material. Next, we should extract all indicators from the script that could be used within a detection query, and based on the actions of this script that was analyzed before, give me specific recommendations for how to respond to this script. And that's really very useful because, okay, we've seen that we have a malicious script and what it does. What could be the next actions, what we can actually do to protect our company. And lastly, summarize the findings from this analysis into an executive report. And we can actually include all the information that we need, like script overview, threat intelligence, response suggestions. Okay, the good thing here when we talk about artificial intelligence is that you can actually write down this information, create this report suitable for a less technical audience, because probably you want to give this report to your manager and your manager is not a highly technical person. So Copilot for Security should use something like, let's say, a language that this manager could understand. And this is another prompt that you can use in a prompt book. Let's do this by using, again, a logic app in Microsoft Azure, in the Logic App Designer. And what we can do, we can check in that incident from Microsoft Sentinel if there is a script. If there is a script, run a script analyzer using Copilot, summarize the data, add a comment to that specific incident, and probably the next step could be to send all that information in an email to our security team in the company. Okay. And that's actually what we can get, the activity log that could be summarized by using Copilot. This is the incident activity log that was actually produced by Copilot, and it gives you all the information that you need to know. So in this specific scenario, we had a PowerShell script that was identified that decodes a base64 encoded command to retrieve a URL and execute a function to obtain a user PRT, primary refresh token. You can get all the actions of what the script does. If there are any threat intelligence information that you need to know, so what are the URLs that this actual script will use? And finally, you get the response suggestions. Microsoft Copilot for Security will give you the immediate response actions that you need to do. Isolate the affected system, block the URLs and IP addresses, incident response team activation to notify the incident response team, and so on. So you get all the activity log with information that will be very easy for you to understand. And the best part is that it shows you what you need to do in order to protect your company. Another one could be that one. We could use Microsoft Purview Data Security Posture Management for that one to uncover and manage hidden data risks. And let's take a look at this one. I don't know how many of you are familiar with Microsoft Purview portal. In this specific scenario, we would like to use the data security posture management in Purview. So the thing here, the case is that we would like to detect sensitive data leaks. Maybe we have some sensitive company files that were shared outside our organization by using SharePoint in the last week. So as you can see, Copilot has some ready-made prompts here that you can use, and we're going to use that one. So show me which sensitive files were shared outside the organization from SharePoint in the last week. And this is because we have a SharePoint site with some sensitive information here. So as you click on that one, it will give you the information. This is the response of Microsoft Copilot for Security. In the last week, the following sensitive files were shared outside the organization from SharePoint: the first file, the second file, the third file. Okay, so probably the next thing that you would like to do is to use some prompts that Copilot for Security suggests you. For example, what are the labels on these files? And if you're not familiar with Microsoft Purview, uh, the information protection mechanism of Purview can use labels, sensitivity labels. For example, a document that is confidential should get a label that is called confidential, and we can create policies to protect all the documents that have that specific label. For example, we could create a security policy to protect these documents from being able to be shared outside of the organization by using, let's say, as an attachment in an email. As soon as the user tries to attach a sensitive document in an email, this email cannot go outside the company, cannot be delivered to recipients outside of the company. So another example could be to show me the users who shared above files externally. Or another one could be show me activities involving highly confidential labeled files. Okay. Actually, what I'm going to do here, I'm going to type in as a Copilot prompt, what are the labels on these files? Okay, we've got 3 files, but are they considered sensitive? What are the sensitivity labels? And you get the information about the sensitivity labels. This is a general label, and this is a non-business label. Okay, and something else we could do could be that one. Provide a list of all label downgrade and exfiltration activities on this specific SharePoint site. When we talk about a label downgrade, means that if a file is considered a sensitive file, a user could change the file to the label of the file and make it a general one or a public one. Okay, this is very important because it will change the policy that will be applied to that specific file. If I have a file that has the label confidential and the user will change it to public, everything else, all the policies that are applied to this file change. Okay. The next thing I could use is that one as a prompt. Provide a list of all label downgrade and exfiltration activities on files with Project Obsidian information, and will give me all the information, uh, everything that happened on the last 30 days. Here are all the label downgrade and exfiltration activities performed on these files. Okay, this specific file had the label downgrade and the actual date and time of this downgrade. This one also, this is an exfiltration activity. The meaning of an exfiltration activity is actually that someone tried to copy the file using a USB stick or upload the file to Dropbox or Google Drive or whatever. All these are considered exfiltration activities. And we have another exfiltration activity for that specific file here, that specific Word document. So, okay, we get the information, but we need to know what we should do next in order to uh, prevent this to happen in the future. So we can ask Copilot, how can an adaptive protection policy help prevent this in the future? And Microsoft Copilot will give you all the information that you need. Adaptive protection in Microsoft Purview integrates inside the risk management with data loss prevention to dynamically and all this information here. Okay, so you know what to do. You've got the information about this exfiltration activities and label downgrades and all these things, but you get, let's say, um, information about the next step. For example, in this case, how could you use adaptive protection in Microsoft Purview? Okay, another one could be to troubleshoot issues on Windows devices, or let's say, generally speaking, devices. And we can do this because we can use Copilot for Security in Microsoft Intune. And when you go into the Intune Admin Center, you get these specific uh, tasks here. Get help with settings while creating a new configuration policy for devices, and let Copilot analyze the potential security impact of a policy. And another thing that you can do is to quickly analyze apps and policies assigned to a device to help determine issues affecting your users. So I'm going to use one of these, and in this specific demo, I would like to type a device query. I would like to get some information about my devices that are already present in Microsoft Intune. As you can see, Copilot has some prompts already here. For example, showing me all my Windows 11 devices, showing me devices that have a TPM version 2 chip, or showing me the devices with an Intel CPU and so on. Okay, but I want to ask something more specific than this. And this is what I want to ask. Show me how many devices are running the Windows version, that specific version, and have not patched in the last 20 days. Summarize the recent updates count, display the device name, OS version, and architecture for those devices. And when you run this prompt, Microsoft Copilot for Security will create for you the query that you need to do. Okay, and you can actually add and run or just add it to the editor up here. Okay, and when you add it to the editor and you run it, you have all the results that you need. These are the devices that belong to that specific query. And actually, something that most people cannot really um, understand it, that all this information here is clickable. You can click every single device here to get information about that specific device in Microsoft Intune. Okay, another thing that we can do, I would like to use Microsoft Entra, the so-called Azure Active Directory. Now Microsoft call it Microsoft Entra. I would like to use Microsoft Entra to quickly access user risk and get remediation recommendations about user risk activity. So if you go to the identity protection dashboard, you can use some prompts that are already there. For example, list the most recent risky users in my tenant, or show applications from outside my tenants, and so on. But what I want to do here is I want you to show me my most recent high risk users. And Copilot for Security will get all that information. As you can see, we have 4 users here that are considered a high risk users. And if you click on a specific user here, you can go directly to that specific account of the user and get all the risky users details about that specific user. And what we can get here, first of all, is a summary by Copilot. So this specific user has one recent risky activity with high risk. The risk detection type is attacker in the middle. What it does anyway, you get all that information. And of course, it lets you, if you want to create a sign-in risk-based policy or create a user risk-based policy, because we always want to think about the next step. Okay, but in this scenario, I would like to do something else. I want to type as a prompt here, show me the sign-ins for the user one day before the alert, because I want to, let's see, examine the sign-in activity of that specific user one day before the alert happened. And I get all this information, all the sign-ins for the previous day for that specific user. The user signed in by using a browser on a Windows 10 device using Edge browser, and again was he signed in using again a browser here. Success, multi-factor authentication requirement satisfied. So at least I know that I'm secure because the user actually used multi-factor authentication. All these sign-ins from the previous day. And next, I would like to ask Copilot what multi-factor authentication methods are available for that specific user. At least I want to know that the user is secured. Okay. Okay, I'm good to go because I can see that Microsoft authentication method is already enabled on this user's iPhone. Okay, so at least I know that there is, let's say, a good chance of security for that specific user. Okay, but the next thing is to get recommendations about Copilot. So what should I do to remediate the attacker in the middle thread for that specific user? And I get a long list of all the steps that I need to do. Some of the steps could be to reset the user's account credentials, revoke access tokens of the compromised account, and all these different steps that you can do as recommended actions. Okay, so what is this? Imagine, and I want to tell you a story now. Imagine that it's let's say mid of July, mid of August. You are on vacation in the lovely island of Mykonos in Greece, and you actually want to get a drink sitting in this bar here by the sea, and you check your emails and you receive an alert from Microsoft Defender XDR. Okay, so this is going to be a scary one, but we will tell all the story from the beginning. Okay, so you check through Microsoft Defender XDR incident and you discover a suspicious PowerShell script that was executed. Okay, and you need now to solve the mystery using Microsoft Copilot for security. And as soon as you log in to Microsoft Defender XDR, you check that specific incident and you find that there is a script, a PowerShell script, actually this one. Okay, think about you are in Mykonos, it's mid-August, and you see this, and you say, oh my God, what should I do now? This is a base64 encoded PowerShell script. Actually, it's a wall of text. Nobody can really understand what it does, but you have to find a way to solve that specific case. Okay. But let's see how everything started, because Copilot for Security can analyze the whole story for you and give you all the steps in between. So let's move to a demo video that I've created, and everything starts like this. Okay, what you get is an email for a specific user. That email it seems to be malicious, but anyway, let's take a look at this. The email message says, Mrs. Robbins, we've detected an issue with your account, Lynn Robbins. Please validate that you own this email address to begin addressing your issue to prevent disruption to your service. And actually, that email message asks the users to click on that one, on that specific link. Okay, but since we have educated users in our company, the user already knows that he can do this. Take a look at this. He can click on that button and report as suspicious that specific message to Copilot for Security. And this information will go to our security team inside Copilot for Security. As you can see here, I have created a logic app, as we've seen before in Microsoft Azure, because we want to better use that information to understand what really happened. Okay, in this specific logic app, you can see that it can check the attachment if there is a script in that one. Okay, it will set some variables anyway here. It will parse the email message But the good thing is that Copilot for security, apart from all that technical things that it can do, it can summarize the email intent. What is this? It can actually go and check the, let's say, the body of the message. So take a look at this. In the following series of prompts, we will assess data to determine if an email is phishing email. So analyze the body of this email for malicious intent and legitimacy. Indicators to look for: sense of urgency, phrases like act now, urgent action required, or immediate response needed, or some generic greetings such as dear customer, dear user, or hello friend, spelling or grammar mistakes. Think about this. All these phishing emails usually contain spelling or grammar mistakes, so Copilot can check for that one. Frequent misspellings, improper grammar, and so on. Or maybe too good to be true offers, promises of large sums of money. eh, you are familiar with all these phishing email messages that usually follow that specific, let's say, template. Okay, so the good for artificial intelligence that it can actually go and analyze the the text and the intentions of the sender of that specific email. Okay, so when we finish with a summarization of that specific text, the next step in this logic app is to initialize variable attachments and, of course, check if there are any attachments in that specific email. If it's true, it will submit a Copilot for security prompt and actually analyze the attachment, which is now really very good. This is really technical here because we want to analyze the attachment to check also if there are any domains for domain reputation. This is another important step that we can use. Copilot can check through Microsoft Defender Threat Intelligence for domain reputation. What is the actual sender, or is there any domain information in that specific message? Probably there is. So let's go and get the reputation of these specific domains using Microsoft Defender Threat Intelligence. So, okay, and as soon as we finish with that specific logic app, let's see what the next step is. Finalize and score the message. So actually decide if this message is a malicious one. And we'll create a report. And as you can see, it will create a beautifully crafted email message as an investigation summary. And this message will go to our security team and we'll have all that information related to that specific email message. I want you to take a look at this for a moment. Domain subject consistency. This specific domain does not match the expected domain for a legitimate support team email. Okay, and remember this specific domain because we're going to use it later in our case here. But Copilot actually realized that this is not legitimate. Something's wrong here. Okay, so that email message will go to our security team for further investigation. And what the security team will do, let's move to the next step. And the next step could be this: to check the session ID for that specific email. This is a security copilot session using the standalone experience. And as the security guys go into that one, they can use, first of all, Microsoft Purview information protection and the data loss prevention solution that it's there. As you can see, there are some alerts here. The first one is this one: a DLP policy matched for a specific document in OneDrive. And if you check that specific alert, Copilot for Security can give you additional information about what really happened, why we have a DLP violation. Okay, so we could type summarize alert. So give me specific information for that specific alert. Okay, Copilot will do the job and we will get all this information that we need. Let's take a look at this. The file involved in this alert is January sales order. It's an Excel file. You can actually click on that one and check the file. But the policy responsible for this alert is named Default Finance Information Protection Policy. So this is a policy that we probably created in Purview to protect our financial documents. Okay, so we can move. And by the way, in some cases, you don't need to type anything. You can use the prompts that are already suggested by Copilot. For example, that specific prompt says what activity was performed on the data on this in this alert. Okay, let's click on that one and let's drink some water as Copilot does the job. And the information that you get is this. We wait a little bit for Copilot to do the job, to see the activity that was performed on this specific data. Okay, the activities are DLP rule match two currencies, a label was changed, two currencies, a file was uploaded to cloud, one occurrence, and a file copied to removable media, one occurrence. And let's describe the sensitive information, file labels, or data triggering this alert to get more information about that specific information protection alert. So again, you don't have to type anything, you just use the prompts that Copilot suggests. So take a look at this. We get some more information here. Let's run it a little bit. Okay. So these are the file paths that are involved in that specific alert. These files contain two credit card numbers, social security numbers, US driver's license number, US physical addresses, full names, and so on. Okay, so we now start to have an idea of what are these specific data, what is included in these Excel files. Okay, and since we know, and take a look at this, we know which user is actually involved in that specific incident. This is user leaner. Okay, let's go and check some information about that specific user. Now we move to Entra ID Admin Center, and we should use again here Copilot for security to get some more information about that specific user. And let's see what we can do. When you click the Copilot button, again, you have Copilot to help you. Okay, we can use, or let's say type a prompt here. And the prompt could be, what is the user risk status of Lynn Robbins? That specific user we've seen before. And her colleague, Jonathan Walcott, because we know that these guys work together in the same department, in the same office. Are they considered risky, these users? And Copilot will do the job and will give us the information. And the information could be something like this. Lynn Robbins is not considered a risky user, but user Jonathan is currently considered at risk with a high risk level. Okay, so let's click on the risky users report in Entra ID protection to check that specific information. And as we have all these users here, let's go and check Jonathan. What is wrong with Jonathan really here? Okay, risky user details about that specific user. And we have something really important here. User Jonathan has one recent risky activity with high risk. The risk detection type is possible attempt to access primary refresh token. And of course, it can tell you here what is this attempt, what is all about. But since we have some more information about that specific user, what should we do? Let's see what else we can do. Let's type at the Copilot prompt here, and let's see. The next thing that we could ask is, what are some recommendations for how to protect my users against PRT attacks? And Copilot will give you all the recommendations that you need to know. Okay, use TPM, enable multi-factor authentication, and all this information that you see here. Uh, okay, the next step could be, now that we know some information about this user, how would I go about creating a risky user policy? Because it's a good idea to create a risky user policy in Enter ID. Okay, and what should I do? It will give you all the steps that you need to know in order to create a risky user policy, step by step. There is no excuse. You have everything that you need to know here. Okay. And maybe we could ask something more. What are some conditions for this policy that I should include? Okay, and Copilot will give us the results. Okay, let's see what information should we get. So to create an effective risky user policy, consider including the following conditions: user risk level, sign-in risk level, exclusions, access control, and so on. Okay, now we have all the information that we need, and let's see what could be our next step. Let's move to threat analytics in Microsoft Defender. Microsoft Defender Threat Analytics gives you all the high impact threats, the latest threats that Microsoft knows about, threats that happen to every single data center in the planet. But we can use the Copilot in Threat Analytics to ask for some specific information. Do you remember the domain name that was included in the email message that the user received? So we can ask Copilot what is known about the indicator, and we just type the domain, that specific domain name. This was included in the initial email that we received in Mykonos, if you remember. Okay, so the response could be something like this. It will check the entire database in Threat Analytics and will give you that specific response. So the indicator, this specific domain, has been classified as malicious with a reputation score of 100. Okay, this domain is associated with the following intelligence profiles and articles: Storm 0300, and actually, as you can see here, it's classified as a ransomware. Okay, and this is the specific indicator, and actually you get the IP address that this domain resolves. Okay, so now that we know that this indicator is a malicious one, the next step could be to ask some more information about that intelligence profile, Storm 0300. So what report is available for that specific intelligence profile, Storm 0300? And Copilot will give us all the information that we need to know. Let's see, what should we get? Okay, sometimes it will take some time. Okay, so as you can see, we have a long description of that specific intelligence profile, but the scary information is actually here. Currently, there are 73 misconfigured and 0 vulnerable devices associated with this activity profile. So there is something that we could do in our company, in our devices, because somehow we are misconfigured and we need to find what are these misconfigurations. Okay, so what the next prompt could be: what assets are impacted by this threat actor? What are the computers, actually the devices, that are impacted by this specific threat actor? Let's see what we get here. Let's see. Okay, sometimes it times out. You need to refresh it, or you need to regenerate the prompt. It happens. Sometimes it depends on your internet connection. Okay. Eventually, it will give you the information that you need. Okay. So the information that we get is two specific devices, as you can see here. No, actually, it's more than two. Users with their SID names, mailboxes, cloud resources, and so on. Excuse me. Okay, and now we can use another prompt to check about these specific devices. Okay, incident IDs, all the information that it could take you hours to go and discover. And now we know that something happened. We could move to incidents in Microsoft Defender and select a specific incident, the one that was described by Copilot in this previous screen. So this is actually a human-operated ransomware attack that was launched, and you can check all the attack story here about this specific incident. And as you scroll down, you find that there is a suspicious PowerShell command line executed. And this is the actual scary script that we've seen in the beginning. The good thing here is with Copilot, we can analyze that script. So we click on Analyze, and Copilot will decode the entire script and will give you all the information that you need. Okay, so the script starts by making a request to that URL, and then it will use this and this and this. I can see some scary things here like mimikatz. I don't know if anybody knows about mimikatz. It's really scary anyway, but we've analyzed the script and we know what to do. So now we know that there are some devices um, involved in that specific incident. Let's go check these devices one by one. This is a Windows 10 computer. The first prompt that you use in Intune is to summarize this device, show me information about that specific computer. Okay, so we get the information, everything that we need to know, which user uses that information. We see, by the way, that user Jonathan uses that specific device. Okay, another good information that we could get is to show applications on this device. So we can use Copilot to do that for us. Okay, and we will get a list of all the applications. Okay, everything seems normal here. Okay, nothing really strange here. Okay, the next thing that we could do is to use the Copilot prompts and compare this device with another device, something really very good that we can actually do with Copilot for security. Let's compare that computer to another Windows 11 computer. And first of all, let's check the hardware. It will give you a comparison of the hardware, and not only actually the hardware, it'll give you more information than this. Okay, this is the comparisons. We can see that these computers seem identical, but I would like to check a little bit more. Let's compare this device with another device, another one, and let's select as the option here to check the compliance policies. Is there any difference in the compliance policies for these specific devices? So you run the prompt. You check both policies. As you can see, there are no difference. Both devices have the same number of compliance policies, but probably it's a misconfiguration. So it could be a good idea to check the configuration profiles on these specific devices. So we go on, and probably this is the last step of the investigation. So as you can see, sorry, there is some kind of difference. Okay, one computer has a configuration policy applied, the other computer does not have a configuration policy applied. Okay, so probably this is what we need to do. Of course, you can use Copilot for security to check for what is the configuration profile on the first computer and apply the same settings to the next computer. So the last thing that I want to tell you is how can you get it? How can you get Azure Copilot for security? Actually, is an Azure capacity. It's a subscription, So you need to use an Azure subscription. You need to create your Copilot capacity by specifying how many secure compute units you want to use. Okay, so actually you give the capacity a name, you specify the prompt evaluation location that you want to use, and you specify how many security compute units per hour you want to use. And you can see the price of the estimated monthly cost of each secure compute unit. Okay, and if you want to check the cost, you could actually use Azure pricing calculator. And as you can see, if we use the West Europe region in Azure for 2 security compute units per month, the monthly cost could be more or less 5,600 euros. Okay. Microsoft, by the way, recommends to start with at least 2 security compute units per hour. Okay, so thank you very much. I think I'm actually on time. Okay, so um, let me see. I will stop sharing my screen. Okay, I'm checking if we have some questions here. No, I cannot see any questions. Let me check the
I
code.
have a doubt, Chris. Am I audible?
Yes, okay.
Yeah, actually, it's a very good seminar. Like, I have a doubt on it. Like, if you have said that XDR and Microsoft Sentinel used for threat detection and threat response. So, which type of application that we can use this EDR and Microsoft Sentinel?
Uh, I'm sorry, I could not hear you very well. Can you repeat the question, please?
Yeah,
Uh,
in which application can we deploy this type of security practices?
well, have you ever used Defender XDR or Purview Information Protection?
Um, I have used Defender. I
Yeah.
have used
Okay.
Microsoft Defender.
I could say that it's not really related to applications. You can actually get all the signals and all the information that you get from the security products like Microsoft Defender XDR and use that information to give you, let's say, a better understanding of what really happened. As you've seen in the exams, we were talking about some specific security incidents that happened.
Okay. In Copilot security, like you have said that in by using XDR, with the use of Copilot, it actually generates the codes that can be implemented for security purposes.
Hmm.
So how
Yes.
much does it take to use this Copilot in security purposes?
Oh, sorry, is this a question? I really didn't understand what was the question. Tell me
Yeah.
again, please.
Yeah. How much does this cost to use this Microsoft
Ah,
Copilot?
okay. This is the last slide I was showing you. It's if you use 2 secure compute units as Microsoft suggests, it's approximately 5,600 euros per month, assuming that you let it run 24 hours a day, 30 days a month. Okay. But of course, if you want to analyze everything, it doesn't make sense to stop the service in order to save money. Okay. Anything else?
No other doubts. Thank you for being a part of this session,
Okay.
and it was a
Thank
wonderful
you.
session on Copilot and security. So thank
Thank
you
you
very
very
much.
much.
Thank you very much, Chris.
Thank you. Okay. So I wish you all a great evening and have a great sessions day. Okay. Thank you very much. Bye bye.
All right. I'm going to welcome Hakan right now. I know we have Patricia with us. Patricia, I'm going to share with you the other link so you can connect to the other room. Wait for my message in LinkedIn. Hello, Hakan. Welcome to Azure AI
Hello.
Connect
Oh, thank
uh,
you. Thank you so much.
video. Um, we are very excited to hear your session. Your session is about how to enhance our own AI services with semantic kernel, a very interesting thing, and I believe most developers will be excited to hear what you have to say about it. Just a few words about semantic kernel is something that I'm using, and it is really a lifesaver. Uh, uh, the way it has built in SDK into the SDK, it has built in everything you need for your AI. It's amazing. I'm going to shut
Mm.
up now. The stage is yours. Please share your screen if you haven't, so I can add it to the stage.
Yes, one moment here. Yes, so thank you so much. So, welcome to my session here on how you can enhance your own AI services using semantic kernel. So my name is Håkan Silvernagel. I am an AI evangelist at Supersteria, and I'm also a Microsoft AI MVP. Now, before we start with this session, I would like to give you some more context around a small use case and application that we're going to study during this next 50 minutes. So I'm from Sweden, and in Sweden we have a Christmas tradition of writing something we called a Christmas rhyme. So the Christmas rhyme goes together with the Christmas gift, and it gives you some sort of hint on what you can expect to receive as a Christmas gift. And in addition to the Christmas rhyme, you will also have a handwritten illustration of the gift in the package. So I was thinking that maybe I can use AI in order to simplify this creation of the Christmas rhyme and also the creation of this illustration. So let me switch over here to the browser and I can show you what the final application looks like. So here we can we can select a gift. So let's say that we want to give away a book here as a Christmas present. So we select the book and then we can push this button to create a rhyme. And then behind the scenes, what is happening is that we're calling Azure Open AI and a language model that has been deployed on that. And that language model will return here a Christmas rhyme. So if we have a look here at the rhyme, so for this book, it says, in pages filled with tales so grand, adventure await, just take my hand. Cozy up by the fire, a cup of tea, with this book pure joy you'll see. I think that's quite a nice rhyme. It's certainly much better than what I would have been able to come up with myself. We can also get here an illustration, an image. So what is happening here is that we're using semantic kernel in the background, and semantic kernel is calling out to Azure OpenAI in order to get an image prompt, and then we're using a special service here in order to retrieve this new image. So we send the image prompt over to a DALL-E 3 model, and then we receive a URL for our image. And then we have also specified that we want our image to fulfill some criteria, that it should be Christmassy, you should have Santa Claus, and you should also have the gift here in the illustration. So in the remainder of this session, I'm going to explain to you how did we end up with this solution, and I'm also going to show you how you can do some rapid prototyping in Visual Studio Code, and then how you can transfer the results from Visual Studio Code over to a more complex solution in Visual Studio. But let me get back here to my presentation. So, so before we start, I can just give you some more information about me. So I work as an AI evangelist for Supersteria. I'm also Microsoft AI MVP, a Microsoft certified trainer, and also a Microsoft certified trainer community lead. And I'm going to give you a QR code so that you can connect with me on LinkedIn if you want to at the end of my presentation. I'm also quite involved both in the local user community in Oslo, Norway, where I live, but also some virtual user groups. So I'm a member of the Oslo AI user group and also the Norwegian.net user group in Oslo. And I'm also part of 2 virtual meetups. One is the AI 42, which is an online AI school, and another one is the Azure User Group Sweden that I'm running together with Jonah Anderson, who's also an MVP. But now, for the agenda here for today, I'm going to first be describing here AI assistants and AI agents and describe some of the differences between these two. Then I'm going to go more in depth into semantic kernel, and we're also going to touch on a tool called Prompty, which is very useful in this scenario. Most of this session will be spent in either Visual Studio Code or in Visual Studio, so there will be many types of demos. And I'm also going to provide you with some QR link to the GitHub repo so that you can try out these demos yourself. And I will give that to you in the summary part of the session. But first, we should talk a little bit here about AI assistants and AI agents. So probably many of you have already tried out AI assistants. So they usually come in the form of a chatbot, like it could be ChatGPT or it can be a Copilot. And they represent something that we call a conversational AI. And you communicate with the AI assistant through prompts, and the AI assistant will be able to give back a recommendation based on the data that it has access to. Then AI agents, on the other hand, they don't require prompts. Instead, you give the AI agent a goal, and then the AI agent will be able to both do planning and create a workflow in order to achieve that goal that has been given to it. So we're going to have a look here in a short while on how we can use semantic kernel in order to create these types of AI agents. So semantic kernel is an open source framework, and it works as a middleware between the AI models and your own application code. And we can develop in semantic kernel either through C#, Python, or Java. And we can also develop our own plugins, or we can download plugins from GitHub or from some other repository. And if you want to connect to some external services, maybe you have a weather service or you want to do an internet search, you can do that through connections. And now on this slide, we can see here that the AI services provided differs a little bit here depending on which language you choose to use. So for example, in our Christmas rhyme example application, then we could see that we were using the text to image service in order to be able to retrieve this Christmas illustration. And for that reason, we needed to use the C# because that's not currently supported in Python or Java. Then, as I mentioned, I'm also going to introduce another useful tool here that is called Prompty. So Prompty is a tool which enables you to work much more efficient with your prompts. So Prompty is now supported by both LangChain, semantic kernel, and also prompt flow. And you install Prompty as an extension to Visual Studio Code. And if you do that, you will get a new file suffix called .prompty, and you will also get a template. So in this template that we can see here on this slide, we give the Prompty file a name and the description, and we also have to give it some model parameters so that it can connect to a model, and then we give it some sample context, and a system prompt. And then we can very easily try this out by pushing this play button up in the top right corner. So prompt is a very useful tool in order for us to do rapid prototyping, because the only thing that we need to change here is just to change this prompt file, which in essence is just a text file. So it's very easy to make changes to this text file and then run the updated prompt file and see if it works as you want it to work. And we can also see here that prompt is also supported by prompt flow and LangChain. So with prompt flow, you will get the playground. So if you don't want to use this more programmatic approach in Visual Studio Code, you can try out this this playground approach instead here through prompt flow. And the way that we can use our prompt files is an example of. So first, we're extracting some configuration parameters to our Azure OpenAI instance and our model. So we get the API key, the deployment name of our model, and also the endpoint. And then we create the semantic kernel object, and we specify that we want to use this chat completion service. And then we provide it with some arguments. And then on line 29, we create a function from this prompt file that we just saw. So then semantic kernel will use the prompt file and create a function that we then can call on line 31. Here we invoke this function and we get the results back. And then we can do what we want to do with that result. So now when we've gone through some of the basic information about semantic kernel and prompt, I would like to give you some demos. But first of all, we should start here from the beginning. So semantic kernel is not an AI model. It's just a middleware that sits between your application code and the AI models. So the first thing that we need to do is we need to deploy an Azure OpenAI instance. So let us go over to the Azure portal. Let me just switch here over to my browser here. So now we've come to the Azure portal, and then we can create a new resource. So here in the new resource, we can search here for Azure OpenAI, and we can specify we only want to have the Azure services. And then we can see here that here we have an Azure OpenAI resource. So we can create this resource, and we specify a resource group, a region, a name for our resource, and also a pricing tier. And if we do all of that, then we will get here an Azure OpenAI resource that we can use. So I've already done that. So here we have the resource that we're going to use here for the demo and for the examples. So if we click here on endpoints, then we can see that we have an endpoint which is obfuscated right now, and we also have some API keys. So using the endpoint and the API keys and also the name of a deployed model, we can use all of this together with semantic kernel in order to create our AI agent. But first, we also need to deploy a model. So then we can go here to the Azure AI Foundry portal. So if we go to this portal, then we can see here that first of all, when it loads, we get the chat playground where we can try out things. But we also have here a deployment tab. So we can see here the different models that we have deployed. So for our example application, we're going to be using this GPT-4o mini model. And for the illustration, we're going to be using the DALL-E 3 model in order to create that beautiful image that we just saw. So that's important here, just to clarify that the semantic kernel is not an AI model. It's a middleware that sits between your application code and these models that we have deployed here. So then we can go over here to Visual Studio, and I'm going to show you some demos. Let me switch over to Visual Studio. So I'm going to show you a couple of demos here on how we can use semantic kernel in order to create some plugins, so that we can give the agent a goal, and then the agent will be able to figure out what functions should I call and in which order. So in our first example here, we are creating a kernel object first, and we define here that we want to have this Azure OpenAI chat completion. And here we are using the deployment name, the endpoint, and also the API key that we can retrieve here from the Azure portal and also from the deployed model in the Azure AI Foundry portal. Then after that, we build our kernel object and we get this chat completion service. And then we can load our plugin here from a specific directory here that we call plugins. And then we have a class here that we called lights plugin. So if we have a look here at the lights plugin, then we can see that this is a regular C# file where we have defined a lights plugin with some different parameters. We have an ID, we have a name, we have also a Boolean if the light is on or off. And then, then we have marked up some functions here with the name here, kernel function. So that means that with that markup, then semantic kernel will understand that this function I will be able to use. And we also have a description so that the semantic kernel can also get an understanding of what does this function do. So here we have the first function is get lights, and it gets a list of lights and the current state, and it returns an array of lights. Then we have also another function, get state, which gives the state of an individual light here and returns the state of the light. And then finally, we have a function called change state, which changes the state of the light. So now, in order for us to be able to use that in our program, then we have added here the plugin, and then we need to enable planning so that the semantic kernel can do its own planning in order to plan in which order should it call the different functions. And then we create here a chat. So we ask the semantic kernel to please turn on the table lamp. And then we will write out the results here that comes from our AI agent. So let me run this and it will be a little bit clearer here what is happening. Oh, sorry. Let me set this as a startup project first. So here we can see what we wanted to happen here is we asked the assistant to please turn on the table lamp, and then the assistant replies back here that the table lamp has been turned on. And what is interesting here to see is that we, as application developers, we didn't need to write any code here in order to instruct the semantic kernel which function should you call in order to turn on the lamp. We just needed to give the semantic kernel a goal that we want the table lamp to be turned on, and then the semantic kernel was able to figure out on its own which function should I call in order to be able to turn on the light. And the way that it was able to figure that out was through this markup of the different functions in our lights plugin. So now we're gonna also try out a little bit more complex example here, where we're gonna have the semantic kernel needs to do some planning. So let me set this project as a startup project. So we have the same lights plugin that we had here from before, and then in our program we are creating our semantic kernel object with the deployment name, the endpoint, and the API key. We build our kernel and we specify that we want to use this chat completion service, and then we add the plugin from this lights plugin class. And then we set the function here that we want to enable planning, And then we start a loop here where we can write some commands into our agent, and the agent will write back the results here after it has issued that command. So let us try this one out. So here we can ask the agent here, get the state of all lights. So here it returns here the status for both the table lamp, the porch light, and the chandelier. And then we can ask it to switch the state of the table lamp. And then the assistant reports back that the state of the table lamp has been switched on. And we can also ask it something like switch the state of all lights. And then we can see here that it switched the state of all lights. So here it needed to do some planning. It needed first to figure out how can I retrieve the state of each individual light, and how can I change the state of all lights, and then finally how can I report back the updated states of the lights. So this is an example here of semantic kernel and the planning. So another thing that can also be interesting here is memory. So let me set this as a startup project. So in this example here, we are using some in-process memory here. So we create our semantic kernel, and we specify we want to use this chat completion. And then we are also using a text embedding model. And then we are using something called a semantic text memory, which is an in-memory store. And then we load this memory store with some information like this thing. So it stores information about the name and the occupation and where they live and which countries they have visited. Then when we have stored that into this runtime memory, then we can ask some questions. And then we can see here, can we retrieve this memory from this in-memory store? So let me run this and we can see what it looks like. Yeah, so now we can see here what we're getting back here from the memory store is both an answer and also a probability. So we can see here on, for example, when we ask what is my name, then it answer with 83% probability that the name is Andrea. And where do I live? It's also 83% that I live in Seattle and have been living there since 2005. So this is a nice way here of being able to store some parameters or some information here in when you're using semantic kernel. And this example is just a runtime memory, but you can also implement a specific interface, and then you can store it in a database of your choice. So now we have seen a little bit more here about what a semantic kernel can do. But then we can jump over here to Visual Studio Code. Let me switch over here to Visual Studio Code. And I'm just going to take some water. So here in Visual Studio Code, we've loaded this Prompty. So we installed Prompty as an extension to Visual Studio Code. And then we get the template that we can fill out. So here we're filling out a name for a Prompty. So we call it create rhyme, and we give it a description. So we say that this is a prompt that uses a gift item as input and creates a Christmas rhyme back as an output. And then we provide it with some model information to the models that we have deployed in our Azure OpenAI instance. So we need to provide it with the endpoint and with the deployment name of our deployed model. And we can also specify some parameters like the maximum number of tokens, temperature, and also what is the format of the response that we will get back. So here we say that we want to get back the response in a JSON as a JSON object. Then we give it some context. So here we say that you should provide a Christmas rhyme for a particular gift, and the rhymes should be in the following format. And then we give it some examples here of how this Christmas rhyme should be structured. And we also give it a system prompt where we say here that you are an AI assistant who helps people with rhymes for their Christmas gifts. And then as the assistant, you will write the rhyme based on the gift item and answer in a personable manner, and even add some personal flair with appropriate emojis. Respond using the JSON format by including the original gift and the rhyme. So we can try this out by pushing this play button here. So then we can see here that the gift item was a cozy blanket, and then we get a Christmas rhyme back, which says, "Håkan, my friend, as winter winds blow, here's a blanket to keep you warm, just so you know. Snuggle up tight with a book or some tea. This gift is from comfort, just for thee." So this is a very easy and rapid way of do some prototyping, because here we only need to make changes in this text file, and then we can push the play button, and then we can try it out and get the results back. So in a similar manner, we can also create this image prompt. So remember that this is just an image prompt, it's just a piece of text, and that we will use this image prompt and send that to the DALL-E 3 model that we deployed. And then the DALL-E 3 model will send us back a URL with the image that it has created. So here we give this prompt file a name, create image prompt, and also a description that this is a prompt that uses a gift item as input and creates an image prompt back as output. And in a similar way, we need to add some configuration that we're using Azure OpenAI and the OpenAI endpoint, the deployment name, and also some parameters. And then we are giving it some context here. So we say that you should take a gift as input and turn that into an image prompt for DALL-E 3. And then we can also specify how we want that image to look like. So here we're saying that the image should always be Christmas themed, with a lot of red colors and winter details in it. There should be either Santa Claus, reindeers, or the Santa Claus dwarves in the image. And we also provide it with a system prompt where we say that you are an AI assistant who helps people with illustrations for their Christmas gifts. As the assistant, you will write the prompt that DALL-E 3 will use to generate the image. Respond using the JSON format by including the original gift and the image prompt. So we can also try this one out here. So then we see here that the gift item was a book, and then the image prompt that we got back here was a cozy Christmas scene featuring a beautifully wrapped book with a festive red cover surrounded by snowflakes and winter decorations. In the background, Santa Claus is joyfully reading the book by a warm fireplace with reindeer peeking through the window and Christmas stockings hanging nearby. The whole scene is filled with rich red colors and holiday cheer. So let's say that now we've spent some time here in Visual Studio Code, and we've done some prototyping and changing both our rhyme prompty and our image prompty. And now we're satisfied with what they look like, and then we can create a program also here in Visual Studio Code where we're putting together our rhyme prompt together with our image prompt. So here we can see that we are here creating on line 35 here. We are invoking this rhyme prompty in order to create a rhyme. And then on line, let's see here, On line 63, we are invoking the image prompty in order to get this image prompt. And then a little bit further down here, we're using a built-in service, the text-to-image service, in order to call out to DALL-E 3. So what is happening is we're calling out to DALL-E 3, and we're using this image prompt that we got here in the previous step. And then we are generating an image, 1024 times 1024, and we are getting the image URL, and then we can write that out on the console and then just paste it into our browser to have a look at what it looks like. So if we if we run this one, then we can see here that first we got a rhyme. So here we can see that the gift was a book, and the rhyme was, "Dear Dad, this gift is quite a treat, a book for you, oh what a feat. With stories and wisdom waiting to share, dive in and explore, you'll find magic there." And if we continue here, then we also get an image prompt. Gift is still a book here, and the image prompt is a cozy winter scene featuring a beautifully wrapped book as the focal point. Surround the book with festive decorations, including red ribbons and pine branches. In the background, add a cheerful Santa Claus reading a book to a group of playful reindeer, all set against the snowy landscape with twinkling Christmas lights and a warm glow from a nearby cabin. And if we continue, then we got here our URL here to the generated image. So then we can take our URL and copy this URL. And then we can switch over here to the browser. And then we can have a look here. So we can see here that this image is very Christmassy with Santa Claus and the reindeers and the book and the gift present. So then what I would like to show you here is that now we have shown here how we can use Visual Studio Code together with Prompty and together with semantic kernel in order to do some rapid prototyping for our application. And then I would like to show you also how we can use these things that we have prototyped and put it into a larger project. So if I switch over here to Visual Studio, so here we are in Visual Studio, and then we can see here that we have a number here of different projects in our solution, and we have, amongst other things, we have one project called Azure AI, which is responsible for everything that is related to the Azure OpenAI service and the semantic kernel and Prompty. So what we do here is in a very similar manner as we had in Visual Studio Code. We add here to our kernel object the Azure OpenAI chat completion service and also the Azure OpenAI text to image so that we can get this illustration that we've seen a couple of times here. And then we build our semantic kernel object, and we also add some functions here. So one of the things that we are adding is this prompty files. So if we have a look here in the file structure, we can see that we have a folder called prompts, and then we also have this create image prompt, which is the same one as we used here in Visual Studio Code. So we can just copy over the files that we used in Visual Studio Code for prototyping into a larger project here in Visual Studio. And then if we go back here, we are also add some different services. Like for example, here we have a rhyme service So if we go into this rhyme service, we can see here that what we get, we're sending over a gift name that we pick out here from the arguments. And then we invoke here, we're using semantic kernel, and we're invoking this special function here, which is the create rhyme prompt file together with these arguments. And then after that, we can get the result back here, which is the rhyme, and return the rhyme here to the calling function. And this, in a similar way here, we are also using something called Christmas image fabricator, where we are also picking out the gift name. And then we're invoking this prompt file, which in this case is this create image prompt with the arguments and with the prompt file. And then we are using the text to image service in order to generate this image with the same dimensions here as we had before. And we return that image over to the calling function. So this is an illustration here of how we can go from prototyping in Visual Studio Code over to a more realistic project in Visual Studio. And another thing that I would like to show also here is if we run this solution, then we're also using .NET Aspire, so we get some interesting functionality. So let me start this, and then we can generate here a new gift, a new Christmas rhyme. So we can see that we got the Christmas rhyme here for a tie, and then we create an illustration. And we just have to wait a little bit here. And there we can see the illustration here of the tie. And what I wanted to show you was that since we're using .NET Aspire, we get some interesting log functionality. So for example, in this log here, we can see when we were calling here the when we were calling our Azure OpenAI instance, we can see exactly how many tokens we have used. So it says prompt tokens 408 and completion tokens 42. So the total number of tokens was 450. And the same thing here when we are generating this image here, we can also see that we had the prompt tokens was 300, and then completion tokens 87, and total tokens were 387. So this is a nice way of being able to keep track here and have some understanding here of how many tokens have been used. And we can also get here also from the .NET Aspire, we can get information here from our application in Azure. So this can be very useful here for debugging purposes. So now let me switch over back to my presentation. So I hope that you found this presentation interesting. And if you want to know more here about semantic kernel, you can scan this QR code where you can get to the official GitHub repo for semantic kernel. And in that repo, you can find all of these demonstrations and many more so that you can try out yourself how semantic kernel works. And if you also want to learn, there's also a Microsoft Learn segment on semantic kernel and introduction to semantic kernel that you can reach here by scanning this second QR code. So if you want to follow me, you can just scan this QR code in order to reach me on LinkedIn. And with that said, I would like to thank all of you who have been watching this presentation, and I'm also open for any type of question. So thank you very much.
Yeah, Hagan, I'm audible.
Yes, yes.
Yeah, it was a really wonderful session. I also learned more about Prompty. Even before Prompty, I used JSON for entire prompting and other stuff. But Prompty is new for me, and I'm sure I will practice after this session. It's a very like informative and fast-paced session. I really loved and enjoyed the session very well. Thank you, Hakan. Thank you for joining. Thank you for making it.
Yeah, thank you so much.
Uh, Perfect. An excellent presentation from Hakan. We will add now a small video. Take a little break while we wait for our next speaker. Thank you, everyone. Thank you, everyone. Be right back with you. Hello, everyone. Welcome back. We have our next speaker with us. Let me see if I can pronounce the name correct. We have Xavier Portilla Edo with an introduction to Firebase, Genkit. We're getting a little bit outside of our usual tech stack, but this event is all about AI. And I believe Xavier has something to important and interesting to tell us. You know, every session is really amazing, and I'm very, uh, how can I say that? Very grateful for every speaker. Let's add the Xavier to the stage. Welcome, my friend. Uh, it's an honor to have you with us in Azure AI Connect 2025. Please tell us a bit about yourself.
Hello. Well, first of all, thank you for having me. Um, I know that I'm gonna be talking about like Firebase Jenkins in an Azure event, but you will know why I'm gonna talk about Firebase Jenkins in an Azure event because yeah, we are gonna be touching the Azure A Foundry, so yeah, it's gonna be very interesting. And for myself, I'm Xavi, as Constantino said. I'm based in Spain, in Madrid, and yeah, I'm working as a head of cloud infrastructure at VoiceFlow, which is a platform that allows you to create no code like agents using like kind of like a no code experience. And yeah, in my free time or in my spare time as a hobby, I am an AI enthusiast. So I've been working on building like not agents, like when we call them bots back in the in those days. So yeah, really happy to be here, and yeah,
Yeah,
I hope you like it.
yeah. You seem an experienced professional. Again, I'm very grateful you are here. I'm glad we can connect. The stage will be yours in a few. Just if you want to share your screen and I can add it to the stage,
Yeah,
that would be perfect.
for sure. Give me 1 second.
Absolutely.
Okay, so gonna share my entire screen. Let me know when this is up and running.
Great. We can see it. So the stage
Perfect.
is yours, Xavier. Thank you very much. You're
Perfect.
better.
Thank you. Thank you so much. Yeah, so today I want you to like to learn a little bit about Firebase Genkit. In fact, let's call it just Genkit. Okay. This is gonna be an introduction to the framework. Okay. But first of all, let me introduce myself. I'm Xavi. You can follow me on social media at Xavido. I am organizer of Madrid DevOps Days Madrid, and also GDG Madrid. Um, and yeah, as I said, I'm working as a head of cloud infrastructure at VoiceFlow. I am an external researcher for Princeton University, working in some agents and all that stuff at Princeton. And I also a bootcamp teacher in the Keep Coding online university. And if you want to learn more about me, I have dozens of articles, and at savidop.me you can find a bunch of like my past talks, articles, podcasts, videos, everything. You have everything there. I've been recognized as Microsoft MVP AI, GD AI, GitHub Star, and also AWS Alexa Champions. But yeah, basically it's all over agents. That's my expertise, but that's like my during my free time, because in my day-to-day job I am working as a head of cloud infrastructure, so just touching like cloud and like Terraform and Azure and all those type of things. So yeah, it's really interesting my day to day. So yeah, what we are gonna talk about, like first, like what is Genkit. Then I wanna showcase the features that we have, and then we are gonna compare Genkit versus other frameworks, okay? And then we will talk about some key takeaways. I have some demos for you that I wanna show you today. But first of all, what is Genkit? Genkit is an open source framework to build generative AI apps. So again, like you can call it Firebase Genkit, but from now on, I'm just gonna call it Genkit, and that's why I'm talking about this product in this talk, in an Azure AI talk, because it is an open source um, framework. Okay, of course, this is built by the Firebase team, but it is fully open source, and you can contribute, you can open pull requests, you can open issues. There's a Discord that I will share with you afterwards, but you can join, and yeah, it connects with all the cloud providers, okay, including Azure. So right now it supports JavaScript, TypeScript ecosystem, and Golang, and it is a generative AI framework that basically is open. It's an open ecosystem through a plugin system. That means that you can create a lot of plugins to connect to any cloud provider. So we will touch that in a bit. And now this is like really, really, really new. They have started developing the Python version of Genkit. So if you go to the GitHub repo, you will see there that the Python is in the kitchen. Basically, it's being cooked. So yeah, because again, it is open source. Okay. So the principles behind Genkit as a framework to build backend generative AI apps are pretty straightforward, and they are like very important to mention. This is really simple to use. When you see the demos, you will see why it is that simple to use. It is very lightweight, not like other frameworks. Like you just add it and it just works, okay, and you don't have to have like really huge libraries. It's very lightweight, production ready from moment one. When you build a code, it's a code that you can like directly deploy and monitor, and it will work in a production environment. Everything as code. Whenever you create anything using Genkit, it's gonna be code. I will show you in a bit. This is one of my favorite things. They have developer tools, they have a CLI and a UI. And for me, that is one of the key things of Genkit, and I will show you in a bit. Okay, so Genkit as a GenAI framework for backend apps to create generative AI apps. What are the features that this framework has? So here is basically what you usually have when you are not working with any framework, right? Like when you are basically interacting directly with the cloud vendors SDKs, like ChatGPT here, Gemini, Olama or Llama, and cloud. You have to install their clients, their SDKs, and then instantiate and like create different clients and so on, which is kind of I would say like a nightmare, especially because in the Gen AI world, if you have been play with the LLMs, you probably will know that there are some LLMs that are good for one thing, there are another LLMs that are good for other stuff. So, you need to play with different LLMs and probably with different LLMs cloud providers like Azure, like Google Cloud, like AWS, OpenAI, Anthropic, and so on. So this is how Genkit solves the issue, and that means that uh, this is one of the methods that you will use a lot when you are interacting with Firebase Genkit. And what that means is, what this does is this is a generate method, and you will specify the model right here. And then the prompt, and for instance, in this case, if you wanna use a multimodal model, in this case is Gemini provision, but you want to use GPT-4o or GPT-4 or GPT-4.5, like any multimodal model, this is how you will call it in this example. But this part, the prompt, will not change. Like you can change this, for instance, instead of set Gemini provision, you can change that for Gemini for GPT-4o from Azure, and that will just work, which is awesome. This is one of the coolest thing that Firebase Genkit has, or just Genkit has, which is an UI. So as you can see here, this is running in localhost, and when you are developing a backend generative AI application with Genkit, it will, this is something that you can turn on and off, of course, but if you have this UI turned on, you will be able to access it and play with the models, play with prompts, play with your generative AI applications, see the traces, inspect what is going on in every single LLM call, just in one place, and it is really easy to use. This is, for me, as I said before, like one of the most important pieces for this framework, because this is something that you usually have if you are using other frameworks, but in the cloud. And here, which is pretty cool, it is running locally in your machine. There are a lot of plugins available, okay? The ones that you are seeing here in black, the Azure OpenAI, GitHub models, Hugging Face, and AWS Bedrock, those are fully written by me and maintained by me. So if you want to use, for instance, GPT-4o or o1 or Anthropic via Azure or Llama, you imagine that you have a Llama deploy on Azure AI Foundry, you can use the plugin that I developed for Genkit and just use it. Same as GitHub models. If you guys are not familiar with GitHub models, I would say like it is kind of like a layer on top of Azure AI Foundry, and just with a GitHub token, you can access to the Azure AI Foundry. I will show you in a bit because it is very interesting. The other ones, OpenAI, Cohere, Anthropic, Grok, and Mistral, those are maintained by the community, and I am the principal maintainer. I am the one that during these past 4 months, I would say, and the one that I'm adding capabilities, adding the new models, and like fixing bugs and all that stuff. And the ones that you're seeing here in blue, Vertex AI, Google AI Studio, and Olama, those are the official plugins maintained by the Firebase team. And then there's a third-party plugin to interact with DeepSeek. That one is maintained by another contributor. And yeah, if you want to use DeepSeek, you can use DeepSeek with the DeepSeek plugin using DeepSeek Cloud, but you can use DeepSeek also with the Azure AI Foundry, also in GitHub models, and also on AWS Bedrock, okay? And there's 2 distilled versions of DeepSeek that are available in Grok, so you can use them as well, okay? And of course, on Hugging Face through inference providers. So what about prompts? This is another thing that I like a lot from Genkit. And as I said before, everything is code, right? So what you are gonna do when, instead of like creating like a big string or like a txt file with a prompt, what you can do with Genkit is basically define a prompt as code. And what is cool of this part is you will specify, like you will use, remember in our past example that we will we were using, the generate method. In this case, we are gonna use the define prompt method, okay? And what it does is, this is really interesting because you will first define the name of the prompt. In this case, it's called hello prompt. But then you will specify the input schema. You can also specify the output schema. And it uses the SOT library, which is a library that has like some adds some like validation capabilities. So you will always know when you are like in the prompt itself and defining the prompt, you will always know what you are gonna get as an input, like the what type of object you are gonna get. In this case, we are input is gonna have a property with the type, well, called name with the type string. So for example, in this case, the prompt here, you will see like $input.name. This is the prompt text, and the return basically is gonna be like the generation itself, okay, like the messages and the text, okay, with the configuration, which is pretty cool because when you are like invoking this prompt or when you are like developing, it's like type safe because you will know what you are gonna get, what you are gonna generate, and the structure of everything, input and output, which is super important, especially if you are working with complex prompts and a structured output as well. If you are using GPT-4o, for example, for a structured output, that works pretty well. This is another way that you have in Genkit to define prompts. In this way, instead of generating the prompt as code, what you are going to have is a different type of files that are called .prompt, okay? So those .prompt files, what they're going to have is basically, it is divided by two, I would say, the file. The first part of the file is going to be the configuration of the prompt itself, like which model you're gonna use, the configuration of that prompt when you're invoking the model, the input schema, and if you wanna define the output schema, you can do that as well. And then here is the prompt itself with some templating, okay? It uses handlebars, which is a template language under the hood. But again, what you are gonna get in terms of input schema, and if you wanna define like the default schema, the default output schema, sorry, you can do that as well, which is pretty powerful because when you are building generative AI apps, what I would say is like when your code is gonna be done like in, I don't know, like in 10 minutes, for example, and then you're gonna spend hours and hours and hours just refining your prompts, right? And sometimes nowadays, what we are seeing as well in the teams is like you are gonna have a prompt engineer and then a software engineer. So with these files, you can give these files, the .prompt files, to the prompt engineer, and the TypeScript code, the Python code, the Golang code to the software engineer. And you can put these files in another repo and reference to those files from Genkit. Okay, so they have like different life cycles because like right now, usually you could have like two different teams, like the prompt engineer teams and then the software developer engineer teams. And again, like when you define a prompt, the prompt like appears, as you can see here, and you can test the prompt as well, okay? Which is a really cool way of testing your applications at the same time that you are developing them, okay? In a UI, super easy to use, etc. I will show you in a bit. This is what I mentioned at the very beginning, but I reiterate this because it is really important. You can, when you are interacting with the LLM with using the UI, like invoking your prompts or interacting with the LLMs, or imagine like Firebase Genkit also has an interaction with a bunch of um, how is it called? With a lot of models, right? So you can interact with them and you can check all the traces, okay? And also if it has a bunch of like plugins with different vector databases, because Genkit also supports vector databases. If you want to build any like RAG applications, you can use Genkit as well. Okay, so whenever, let's say that you have an interaction with the LLM, calling a function, because Genkit also supports functions. I will show you in a bit. And it also interacts with a vector database. You will see the entire trace here. And it is really useful when you are debugging this. And again, locally, because again, this is localhost. And this is for free because it is open source, which is wonderful. And as you saw, that works with the Azure AI Foundry, thanks with the and with the GitHub models, thanks with for thanks to the plugin that I just developed a couple of months ago. So as I said, as a spoiler, Firebase also works with tools or functions. Okay, for those that are not very familiar with like what is a tool or what is a function, basically a tool or a function, what it does is basically it interacts with the real world, I would say. Let's say that you wanna know, I don't know, like what's the weather, and when you ask what's the weather in Paris, the LLM, like it can hallucinate, like it can tell you like some random stuff, because at the very end, the LLM, what it always tries is to um, like generate the next token, like in terms of like that makes sense in terms of like probability and all that stuff. But you can connect the LLM to what is called like tools or function calls, and you can build a function that, for instance, like connects to Open Weather or to AccuWeather or to any weather service to check the service. And what it does is basically you instruct the LLM saying, "Hey, when the user or when you see that the user is requesting information from the weather, please let me know, and I will call the the function." Okay, the function could be written in Python, in Go, in TypeScript, and then when you get the information, you send that to the LLM, and the LLM basically tells you like what's the weather in Paris, but like augmented with real-time information. In this case, what you are seeing here is something similar, but the use case is asking for a tool, sorry, for some nodes that are that are made made by a user. Okay, so we need to check the nodes database. Okay, so here, if we start from the bottom to top, what you can see is the generate method. Okay, and it is in this case the prompt is, we just put the prompt there, but you can create, if you want to, a prompt object, okay, with the defined prompt function. But in this case, we just put it here. Okay, and as you can see, we have added a tool which is called search nodes. The tool is defined over here, defined with a define tool. And here is also something that is like standard and pretty cool as well, because you have the name, the description, that is basically when you're instructing the LLM when this tool needs to be called. And then we have the input schema and the output schema again. Okay, so this tool needs this input schema, and it will give me this output schema. In this case, we are gonna have an object that's gonna contain a property called nodes, and it's an array of node schema. Okay, and node schema is defined elsewhere. And what it's gonna do, as I said, is just search for the query in the database, in the nodes database. Okay, so pretty handy. And I think like if we remove the import lines, we have I don't know, like 20 lines of code. It's pretty straightforward, pretty simple, and pretty easy to use. We have, in this case, Gemini 1.5 Pro, but again, with the plugins that I built, you can use GPT-4o, okay? Which is pretty cool, through Azure Foundry, directly OpenAI, or through GitHub models, which is pretty cool. Evaluations. So far, just like as a quick recap, with Genkit, you can create generative AI apps, and the features that I just explained are the generate method to call and to basically generate content, um, tools, vector databases, prompts, and now evaluations. Okay, evaluations are quite essential when you are building a generative AI application, because you need to check that your prompts and your user inputs are working properly. Because in the Gen AI world, like every 2 weeks, you will find like a new model. So you will need to switch to that model, or the model that you were using probably is deprecated. So you need to switch to the to a newer model, or you need to check that the output of the models are correct, like are safety. There's not, like anything about like hardness, sexuality, and all these kind of things. So for that, you can use the LLM as a judge, what is called also as evaluations. Okay, you can create also your own evaluations to make sure that the with some user inputs, that your AI application is working properly. Okay, here is also cool, as I said, like the evaluation is also a big piece or an important piece, and that is also available in the UI. I will show you in a bit, but here, for example, you have different, like evaluations, and in this case, you have like prompts, and these are the evaluations that are being evaluated. I would say like the answer relevancy, faithfulness, maliciousness. These things are things that you can define. There are built-in ones, but you can define um, more, okay, with Genkit. And again, using the model that you want. If you're working with GPT-4o through Azure Foundry, go for it. That is supported. Observability. This is also pretty cool. If you are building a generative AI application using Genkit, you have OpenTelemetry enabled by default. So if this is part of your microservice, you will see metrics plus traces being populated. So if you are using OpenTelemetry, or if you're using New Relic, if you are using Datadog, those will be like scraped and push to those platforms. Okay, and you don't need to add anything. Those are basically built in the framework. Okay, if you wanna deploy to Firebase, there's also an AI monitoring feature, so that will work if you are using Firebase. Okay, but like we are talking about Azure Foundry and about Jenkins, so no worries about that. But this is a feature that you have available if you want to deploy a Firebase function. Genkit versus other frameworks. As you may know, like we have been talking about Genkit, and it's like, okay, another framework here? Why, right? So Genkit, basically, the team, they designed Genkit from the application developer's perspective. If you have a look to like Llama or Llama Index, sorry, or LangChain or LangGraph, those frameworks were made like by ML or AI engineers, right? That's why like first everything comes to Python and then goes to LangChain JS, and then you're like to LangChain for Java, .NET LangChain or LangChain for Go. So that is why. And also those frameworks like LangChain or Llama Index, like they have a layer of abstraction that is very wide in terms of like the learning curve. All the things that you need to learn to start working with LangChain is pretty wild. Okay. And due to that abstraction, sometimes when you're running code using LangChain, you will see some sort of like delays since there are a lot of abstraction, on top of LangChain. So you have to instantiate a lot of objects and all that stuff. And then when you just want to call an LLM, you have first a lot of lines of code and then a lot of abstraction. So it is pretty complicated. And in this case, what the Genkit team wanted to do is basically just simplify that, like fully simplify that. And as you saw with the code, and I will show you with my samples, it is really easy to use. I would compare Genkit with Vercel AI SDK, which is the one that you have here. But the Vercel AI SDK is more for like front-end applications, okay? The backend side, which is where Genkit is very strong, is not that strong. Like you don't have any like that tooling with the Vercel AI SDK. You don't have that like monitoring, like this nice UI, this nice CLI. You don't have that with the Vercel SDK. That the Vercel SDK is pretty good, but it's more for like the front end side of things. And when you are developing with these other frameworks, like monitoring and debugging locally, is really really difficult. We have with Genkit, we have the CLI, we have the UI that help us a lot to debug what's going on basically. Okay, and scaling them, like when you have like your LangChain application, scaling a LangChain app is pretty difficult. It's also really heavy. Jenkins is pretty lightweight. I think the library is like 5 MB or less, so it is pretty nice. So that's why like Firebase Genkit is designed also from the like from the application developer perspective to make it basically easy to use for non-AI developers. And 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 yeah, that's pretty much it. I have 3 demos that I wanna show you, and then some resources that I wanna share with you as well. So let's go first with this example. This example is basically a translator using Olama. Okay, Olama is an application that you have and that you can install on your laptops if you wanna run LLMs locally. Okay, like for instance, Yema or Llama 3 and so on, or like Phi 3, Phi 4. Those are open source. You can install them using Olama. And you can use Olama with Genkit as well. Okay, so let me show you this example. So first of all, and most importantly, what I wanna emphasize is the number of lines of code that we have, 40. So that means that it's really easy to use, easy to set up, and with just 40 lines, we have a translator using a local LLM using Genkit. Okay, so let's go up. here to the top. The first thing when you are using Genkit is, well, like install Genkit as a dependency in TypeScript, Golang, or Python, and initialize the plugins. Okay, as I said at the beginning, Genkit it has an open ecosystem of plugins. That's why I built the Azure AI Foundry plugin, the Genkit, the GitHub Models plugin, so you can use the Azure models using Genkit. So in this case, I'm gonna add the Olama plugin, and what I'm gonna specify is that I'm gonna use the Gemma 2 model, and I'm gonna point to my local host machine, okay? Because I have Olama running, and if I run Olama list, we will see here that I have Gemma 2 running, which I think is a 9 billion model, okay? And then here I just set the log level to debug, and here I define a flow, okay? A flow basically is like a function in Genkit. You can like call other flows from Genkit, but it's literally like a function. Like imagine that instead of having here like a function definition in TypeScript, you will define a flow. It's exactly the same. Okay, so what you have to specify first is the name of the flow, and then again here the input schema, and then the output schema. So what is cool is that you know what you are gonna get here as an input schema and what you are gonna return as an output schema here using SOT, the SOT library, the validation library, okay? So to translate, basically, it's gonna have a property called text, which type string. So it's strongly typed, okay, which is one of the core principles of Genkit. So in this case, the prompt is translate this to Spanish and auto detect the language. So let's say that I'm gonna say hi, will auto detect the language and translate it into English. And then I'm gonna call the AI generate. With that, what we are gonna do is basically specify the model, then the prompt that I just defined above, and then the config, okay? Temperature set to 1 to be basically deterministic. And I'm gonna reply with what is generated by the LLM. Okay, so let's run this. npm run Genkit start. If you go, when you run this, this uses the Genkit CLI, and it will show up like this message, like, hey, the Genkit developer UI is available in the port 4000. Okay, so let's go there. I have this one already open, and this is the fabulous UI that I was talking during the presentation. So here you can interact with the models, like a playground place that you can interact with the models. With the flows, your functions, okay, like the flow that we have defined here, which is again like a regular function in your code, but in Genkit is called flow. The prompt, imagine that you define a prompt with code, okay, with a defined prompt function, or you have dot prompt files. Those will appear here. Tools, you can test the tools directly here, okay? Embedders, indexers, retrievers, and then evaluators. You have everything in one place, like all the things that you need basically to use when you are developing a generative AI application. It is available in a UI locally, and that is what amazed me, and that's why I think Genkit is one of the most powerful frameworks out there, even though it is basically released on May. Like it is very young, but it is very powerful. So again, like you can interact with the model here. This is pretty cool because I am interacting with Gemma 2, and it is running locally. That's why it's super slow, right? The first interaction takes a little bit. Here it says hi. And then if I click in view trace, again, here you will see the trace with the output tokens, with the latency, like with all the things that you need when you are developing an AI application, a generative AI application in this case, okay? So let's go to the translator flow. With the translator flow, remember that it's basically, it will auto-detect the language and it will try to translate it into Spanish. So I'm gonna say hi, and here it just auto-translated to Spanish, which is hola. And if we go to the trace, we'll see that the trace is I've invoked a flow, the flow called the generate function, and the generate function called directly the model. And the model is the one that I'm running locally with Olama, which is pretty neat. And you can see what happened step by step, which is very powerful. Okay. So I'm gonna stop this this example, and I'm gonna show you another example, which is also in TypeScript. This example is it tells you the weather for a current location, but using a tool. Okay, I'm gonna run the here the local UI. So let's go to the top. In this case, I'm using here. If we go here again, same steps. Genkit, initialize the framework. And in this case, I'm not gonna use Olama anymore, but I'm using GitHub Models, which is a wrapper of the Azure AI Foundry. And what is cool about this is that you just need a GitHub token, just a GitHub token. Like, you don't need an Azure account, you don't need anything, and you will interact with the Azure AI Foundry through GitHub. Okay, which is pretty cool. Let me show you the GitHub models here. Let me go to the GitHub marketplace. So if you go to github.com/marketplace and then you go to models, you will see like this. Okay, so if you go to the full model catalog, what you will see is like literally all the models that are available through GitHub models. Okay, so let's say that you want to test, I don't know, like OpenAI O1. Okay, in GitHub models, you can click on use this model, and you have two ways of interacting with the Azure Inference SDK or with the OpenAI SDK. Okay, you can see here, like just with like a GitHub token, you can interact with it, or you can use the Azure AI Foundry. Okay, so you can use these two SDKs if you want to interact like just with the SDK, but if you want to have like you want to build like a complex application with like building a rack and benefit from like the like of a framework itself, you will need a framework, because the SDK itself is pretty good because it's a wrapper of the API. But when you're building an generative AI application, you will need a framework. That's why Genkit exists, LangChain, and other ones. So if you want to use this model, for example, with Genkit, this is the way. Okay, to install the Genkit GitHub Models plugin and initialize it, and again with just one GitHub token, which is pretty cool. So once we have the Genkit initialized, let me scroll to the bottom. We have a flow defined. Okay, this flow, I call it hello flow, like hello world. And again, we have we call the define flow. We have the name called hello flow with input schema. and it is gonna have an object with a property called location with type string, and we are gonna send it back a string. So we go to the function itself, we are gonna call the generate function. We have a tool here. We will go to the definition that is defined above, and then we have a prompt. Okay, so with the prompt, basically, this is the prompt directly, and again, like it's input dot location. So when you are writing your code, I can just put here the dot, and the IntelliSense is just telling me that it has a location, right? Which is pretty neat. So let's go to the tool. As I said during the presentation, to define a tool, you have to call the define tool function. Okay, you have to define a name, the description, and then input schema and output schema. Okay, so you will instruct the LLM to know like what are the specific things that you need to have when you are calling this function. Okay, and the fact I will go through the schema in a bit, but the function, what it does is basically I just instantiate the Open Weather API client. I'm using the Open Weather service, and I just call the service to get the current weather of that specific location, and I return it. Okay, and the input schema is just an object with a location that is type of a string, and then a describe. Okay, when you are defining a tool, it is important to always define the describe and to add the description of the tool, because this is basically what you are using to instruct the LLM. Okay, so let's see this in action. I have this running locally, and here what you can see, since we have imported we have instantiated the GitHub plugin in Genkit, you can see that we have 39 models. So you can go here and like choose the model that you want. If you are using the Azure AI plugin instead of the GitHub model plugin, you will see a huge amount of models as well. So let's say that I don't know, like I want to interact with GPT-4o as a playground. Okay, we are not calling the flow, the hello flow. Okay, we are just like interacting with the with the model itself as a playground. Okay, so again, like you can call the model from here. Okay, you can also add a system prompt, and for the ones that are multimodal, for example, like GPT-4o, you can add a media even. Like for instance, let's say that I wanna add, I don't know, under icons, new, this logo, and you can say like, what is this, and send it. Here it's gonna try to explain what it is in here. Okay, so it works with images, and also when you are since this is a playground, like interacting directly with the LLM, you can also check the bit traces, but also at any time you can enable the tool in case that you wanna debug it. Okay, you can also interact with the tool directly, like instead of like creating like a small server with the tool and interacting with the tool with that small server, you can invoke the tool directly from this UI. For instance, let's say LA, like Los Angeles, it will call the tool here, and you can also see the trace. Okay, like this is the input of the tool and then the output of the tool. Okay, and then if you want to see everything together, like the flow itself, you can specify here, like what is the weather in Madrid, for example. So when you hit run, you will see that the output is like, who's gonna tell you like the current weather is in Madrid, but you are invoking this flow. This is what we just have invoked. The other thing was basically just a debugging, like running the model directly, calling the tool directly. But here we have the flow like working itself. So if we click on view trace, here you will see exactly the same. Like we have invoked a flow, the flow invoked the generate method. We were using GPT-4o. The method detected the get weather tool, so we invoked it, and then with the output of the tool, we call it again the generate method using the GPT-4o. Okay, so you have the entire trace. So for instance, if we click on here, this is like what we used to call the tool, for example, and it detected that was Madrid. How the LLM knows and how the LLM extracted that this was Madrid? Because in the tool we have added the description plus the like the describe method for the location, like the location to get the weather for. That is where we were instructing the LLM to extract basically the that information. Okay, so that is my second demo, and then the last demo that I have for you today is using Golang. Okay, so let me run this with Golang. It's gonna be the same, but using Golang. Okay, so if you are not very familiar with Golang, the syntax is very similar. As in, I mean, it's a fully different language, but in terms of Genkit, the concepts and everything, it remains. Okay, so the first thing that we will do with Genkit in Golang is initialize the plugin. In this case, we are using Vertex AI to use Gemini. Okay, and then we are gonna use the define flow. Okay, so for the define flow, what we are gonna do is we are gonna create the instance of the model using the plugin. Okay, and then we are gonna call the generate method, but this one is with the Golang version. Okay, but if you translate that into TypeScript, the framework is like very similar. It's exactly the same, but with like the Golang syntax. And then what we are gonna start or what we are gonna return is the text, like the output that we just generated, basically. Okay. This example is basically it tells you an entire menu based on a plate, okay, on a dish, and then we just call the Genkit init to run the Genkit server. Okay. You can for Golang, like you can specify this if you wanna run the Genkit server. But if you have your own server, you can just add this piece, like the generate method, in your source code, wherever you want. Okay. So we'll go here with the Vertex AI client. You have three different models. In this case, it's Gemini 1 Pro, 1 Plus, and 1.5 Pro. And it is exactly the same. Like if I use Gemini 1.5 Pro and I say hi, it will interact with Google Vertex AI. Okay. But here, if I go to Flow and I say it's salad, what is gonna return me is the like the entire salad and entire salad output. Okay, like a menu with salads. Okay, and it called Green Goddess. So yeah, very similar, but of course using Golang in this case. So let's go back to the slides. Let me finish them really quick. But yeah, just to recap, as you can see, like the lines of code that you need to develop AI applications using Genkit is like there literally nothing, like less than 30 codes. You have a Gen AI app running in your backend. It is pretty lightweight, it is production ready, it works with RAG, like vector databases, functions, multimodal. It is pretty neat. It has also evaluations. You can deploy it if you want to Firebase or GCP, but like you can also deploy to an Azure function, to an Azure application, to your Azure Kubernetes service. Like feel free to deploy it wherever you want. Feel free to use it, Azure AI plugin, GitHub model plugin, Hugging Face plugin. This is up to you because it is open source. You can go to the official GitHub and check what's going on there, contribute, and all that stuff. So yeah, available in TypeScript, Go, and Python pretty soon. So yeah, this is basically what I wanted to show you today. You can go to the official documentations. You can also build here, for instance, like OpenAI, Anthropic, Llama, Mistral, Olama. You can like for instance, like generate images as well. You can also build this here. Oh, I think they just updated they just updated the docs, but you can build agents as well using Genkit. There's a, let me see if I can find it really quick, because they just updated the here multi-agent system. You can build agents using Genkit with the chat function, using memory, context, and all that stuff. Genkit also supports that. Okay, so go to the docs again. It is built and maintained by the Firebase Genkit, but just call it Genkit, open source framework that anyone can use with any cloud provider, and anyone can contribute. Okay. There's also this awesome Firebase Genkit GitHub repo that is maintained by me, and anyone is free to contribute. Anyone is welcome to contribute. Sorry. And you can see all the plugins, basically the JavaScript and the Golang, the ones that are official and the ones that are maintained by the community. So you can just jump in here and see like all the the models. For example, like the Azure OpenAI. This one is the one that I built that works with Azure. Okay, so if you want to use the Azure OpenAI AI Foundry, you can just come here, specify the API key of your model endpoint, the endpoint, and then the deployment name, and that's it. That just works with Azure. Okay. So yeah, that's pretty much it. I hope you like it. I know that we were talking about like Firebase and all that stuff, but no worries. We were talking about just Genkit, which is for me the most powerful generative AI framework that to build Gen AI backend applications. So yeah, thank you to the Azure AI Connect team for having me. And yeah, again, if you wanna stay in touch with me, you can follow me at Shavidop on Twitter, Blue Sky, also YouTube. So yeah, thank you so much.
Amazing. Xavi, thank you so much. Is it Xavi or Xavi? What's the best way to pronounce it?
Is both are
Both.
good. Like
Okay, okay.
Xavi depends
Xavi.
on like where you live. Like you can pronounce it in different ways. So yeah.
Yeah, it was a very interesting presentation. I'm definitely going to watch it again. To tell you the truth, I have an experience in Firebase, but I never seen such an approach and such a deep way of explaining how we can utilize it. And yes, I understand why you initially stated that we're going to see Genkit, and you stayed on this word.
Exactly.
We are very grateful for being with us today, and I will stay connected with you, Xavi. Hopefully, we will see you in another event of ours. Uh, Thank you so much. Have a great one. Bye bye.
Perfect. Bye bye. See you.
Bye bye. Well, that was Xavi with an amazing presentation about Firebase Genkit, and I believe we can play a video and see whether our next speaker will join us soon. Give me a moment, and let's have a phone break. Thank you. Hello, everyone. We have Salma with us. Salman is going to present how we can demystify retrieval augmented generation. We are live on our Azure AI Connect. Let me bring Salman on the screen and welcome. Hello, my
Uh,
friend.
Hi everyone, Salman
How
here.
are you?
I'm very well, thank you. How are you?
How are you, my friend?
I'm very well, very well. Can you hear me by the way? Am I
We
audible?
are good. We are
Yep.
good.
All right. Okay.
And thank you so much for being here with us. Salman again is going to present demystifying the development generation. Very interesting presentation. Um, yes, Salman, you're on the driver's seat. The stage is
All right.
yours, my friend.
All right. Thank you for joining. So this will be a short presentation, and objective here is to present some theoretical knowledge regarding retrieval augmented generation. Understand how a basic RAG pipeline works, what are the limitations of that pipeline, and how we can leverage LLMs to enhance a RAG pipeline itself. So large language models have shown remarkable capabilities in generating text, in answering complex questions, as well as performing on wider range of tasks. But what we see is that these LLMs do have notable limitations. So sometimes they generate content which is nonsensical and is not faithful to the provided source content. And this phenomena is called hallucination, and it's primarily down to the fact that these models are relying on the underlying patterns of the training data rather than the solid understanding of the facts itself. So, for example, LLMs can produce inaccurate historical dates. They can produce fictitious citations, and then have scientific explanations which don't really make sense. The second challenge we see with LLMs is that by design, their knowledge is static in nature, so they don't really have the ability to access latest and the newest information. So think of an LLM uh, which is trying to explain maybe global affairs, and for that you need the latest information. So for problems like those, LLMs tend to by design tend to be restricted. Lastly, this is more on the explainability end. The reasoning of LLMs is often non-transparent, and it's difficult for a user to ascertain that okay, the information I am being provided or the reasoning I am being provided is something I can rely on. And this is problematic in high stakes scenarios where accountability is essential. So given so with these challenges in place, uh, how do we solve these problems? And a RAG system tends to give you a very nice framework to get resolution of these problems. So what RAG does is it combines information retrieval, which is like a science on its own, along with generation from large language models. And relying on by grounding or your LLMs primarily on a knowledge base, it addresses the limitation of hallucination and even can provide citation which you can trace back to your knowledge repository and offers explainability as well. So now let's look at a very basic RAG pipeline and try to understand how it works. So with all LLM systems, you have a user prompt. So let me change this to a pointer. Yeah. So like all system, you have a user prompt. A user prompt. So a user asks a question. The first step in a RAG pipeline is retrieval from your knowledge base. So your knowledge base could be a data set, could be a set of documents, PDFs, HTML files, right? It could be structured or unstructured data. The first step in a RAG pipeline is you take this data set and you break this down into consistent and logically coherent data chunks, right? So after you have split this data, you will tend to represent this data in a vector form. It could be a dense representation, or could be a sparse representation. So your sparse representations are your classical um, uh, classical transformations such as TF-IDF or BM25, and dense representations are your embeddings such as BERT and OpenAI embeddings. So again, taking your text data, chunking it into coherent sections. So think of your lots of PDF files. You have made uh, chapters out of that PDF file which could contain the same or coherent content. Then you convert this into a vector representation through some form of uh, transformation. So and then you save this in a vector database. So you've taken your knowledge repository and then you have saved it in chunks in a vector database. You take user query and then you try to figure out, and you can also you also transform the user query through the entire like the same embedding process. Now you try to identify information in your knowledge base, which is present here in the vector database, which is closest to your query, right? So and that's the information you retrieve. So idea here is the content which is semantically most closer to the user query is the relevant content which I want to feed to my LLM along with the user query and use that to generate a response, right? So that's the whole idea of a simple RAG pipeline. Um, but this pipeline comes with its own limitations. So the first and foremost limitation is the user query itself. So the first question is the user query clearly articulated, or if it is not clearly articulated or is not precisely framed, it can lead to ineffective retrieval. The other problem would be the query does not give you enough information so you retrieve the right content, right? So you might not, either you're retrieving irrelevant content and missing out the important information from your knowledge repository. And the other problem here would be that the retrieval system itself, where we talked about, finding the content, which is semantically most closest to the user query, right? Uh, that's not happening correctly within the retrieval system. So these limitations could again lead to similar problems that you have extracted the wrong content, and if you're feeding the wrong content from your knowledge repository to your RAG system, you'll eventually end up producing output which is not desired. So to address this, what you do is you leverage large language models. So it's more or less the same design as earlier. We have the retrieval module, we have the response generation module. But first step you do is you take user query and you enhance that query, right? And this enhanced query or set of enhanced queries is then used to retrieve relevant content from your knowledge repository. After you have retrieved the knowledge content, you tend to order it in a way that the initial contents are the one which you believe are the most relevant one, and then you feed this back to your LLM, and then you generate a response, which you can again validate using a large language model as well. So let's go through a bit more detail on query enhancement. Uh, so what the idea behind so the problem earlier we talked about was that the user query itself uh, is maybe not precise, doesn't have all the details. So the first one of the first step in query enhancement would be you to understand what's the intent of your end user. So for example, I'm building a Copilot or a chat bot which is maybe relevant to my particular product. So think of um, a technical support bot. So what I want to understand is the query user seeking, is it like factual information, is the user asking about product knowledge, a product FAQ, or is the user asking for technical support? So this intent classification can initially also help you to identify the relevant content from your knowledge base. Then you can also decompose query into a long query might be too complex for the RAG pipeline to handle in one go. So you might be able to decompose it and have a subset of set of subqueries which you can leverage to retrieve content multiple times rather than in one go. And then I think context in conversations is important when you're thinking of a chatbot. So even leveraging your historical conversation with the end user, will help you to enhance your query itself. So this is the part where you are again enhancing query using an LLM, and the LLM itself is saying, okay, that I have taken this user query, and these are the 5 categories of intent, and LLM will classify those intents for you. Again, you're also using an LLM to decompose your query. You take your input, and this is all more or less prompt engineering, right? So you're saying, okay, this is the user query, and I want to decompose it into like multiple chunks, and then another LLM can also take historical context along with the new query, and then help you classify user intent or build subqueries more efficiently. So then the second part which we talked about was need like particular focus is the retrieval module. So the idea behind retrieval module is that you're using retrieving relevant content from your knowledge repository based on user query. So we talked about you take your knowledge repository, you separate it out into chunks, and then you transform it into some vector representation and identify the chunks which are more relevant to user query. So even the first part where you are chunking information, right? You can also think about chunking data or your text or your content into groups while making sure that individual groups have a semantically similar information, right? So it's not just like random chunking of data, but making sure that all the content within one corresponding to one vector is all telling the same thing, is all semantically aligned as well. Then the retrieval part, uh, so we talked about the retrieval part where which again you're thinking about identifying content which is most semantically similar. So for that you have different options. So we talked about like classical uh, sparse representation using TF-IDF and BM25, or now you have the other option of using your dense representations using like models like BERT and OpenAI embeddings. So even within those you tend to have like 3 different types of models. So one option is to have a bi-encoder model. So you take your BERT transformer, you pass your chunk data set through that, generate an embedding. Similarly, you do this for your query, and then you're looking at chunks which are identical to your query, so semantically most closest. So thinking of like some form of distant measure between those two vectors, so something like cosine similarity, or yeah. So we tend to use cosine similarity or dot product there. Um, so this is one option. The other option would be to build your data set in a way that the query and so with this design you're treating query and your documents independently. You transform your documents and you transform your query, and then you retrieve chunks which are closest, semantically closest. The other option would be to use a cross encoder model. So this will process query and document simultaneously. So it's like concatenating them together, and then you're processing them simultaneously and generating a single a single vector there. But this is again is computationally intensive, because at each retrieval step you will take your all your documents and take your query, concatenate it, and then you transform it. So this might not be the most computationally efficient method, but it does tend to be the most precise one, because it's considering them together rather than treating them independently. Another innovation here is called Colbert model. So in this design, rather than taking the entire query, you take each token of the query. So you think of like a user query as a long sentence. In the bi-encoder model, what I was doing was I was taking that entire sentence and transforming that entire sentence using, say, like BERT's sentence transformer, and generating a single vector. While with Colbert, what you do is you take each token of your query, you transform it, and then you compare it against each token of your document. So this methodology tends to capture more nuances within the text rather than treating the entire sentence as one entity. Again, this also is computationally intensive, but can be utilized in terms of improving retrieval the retrieval step. So the second important the so yeah so the this was the retrieval part, and the last one is the generation module. So generation module is the one where we take user query, retrieve context, retrieve text, feed it to an LLM, and then generate the right response. So in this part of the RAG pipeline, uh, prompt engineering is the key. So because you're giving LLM some documents as well as the user query, so it will be good to define, LLM that what's the role LLM has to play uh, in this particular prompt problem. Define the goals, uh, provide context, and there, uh, when you're providing context, you can also think of metadata from your knowledge repository. I think that is also very useful there. Then having few short learnings, so giving examples with the desired output can also make sure that your LLM is also giving output in the right format. And in incorporating model reasoning, so that is also generally very helpful in making sure that uh, you get some transparency out of your large language model. So and and the idea here is that you're asking LLM to reason, to give you its thought process or its reasoning behind generation of this particular output. So these primarily prompt engineering strategies tend to be quite useful in terms of improving your RAG generation. uh, so I think I will go back to this picture. So here we talked about a simple RAG pipeline. We had the user query, we had our knowledge repository, which we chunked and converted into a vector database, retrieve the relevant database, relevant documents from this knowledge repository, and fed this, uh, to your LLM to generate the right response. And as we talked about, this was this is potentially limited by two main aspects. One is that if the user query is not clearly articulated, we can end up not selecting the right data set, or if the retrieval part, which is your transformation of your text into a vector format, and then identifying the text which is most semantically closer to the user query. If this part is also failing, your LLM will not gain all the advantages we expect from a RAG pipeline. But by incorporating the LLM modules here itself, right? So by incorporating an LLM to enhance your user query, right? So either creating subqueries or enhancing the query, right? That helps in the retrieval module by design. And then the second step here was, after we have, as we retrieving data, we are relying on better methodologies. So not using your classical um, retrieval techniques of TF IDF, but you're using either a BERT transformer, or as we talked about, uh, biencoders, or a Colbert, right? So those can help you identify more relevant text or more relevant knowledge from your knowledge base, and then you're re-ranking it. So making sure when you're feeding these documents to LLM, you're also giving that insight. Okay, what you feed in an order, that the information you're feeding, the top one is the one which you believe is the most relevant to the user query. And then now, by improving the query, improving the retrieve context, you feed that to LLM, and even this output from LLM could be fed to like a judge LLM, which is also making sure that the response is meeting the right criteria, is giving you the right output, is giving the reasoning, right? So these checkpoints here can definitely help you improve your RAG pipeline. So in summary, like RAG does offer a lot of advantages um, over your classical LLM approaches. It provides more precise, context aware, and reliable information By doing prompt engineering, you can enforce your LLM to provide citations, so your output is more traceable, more explainable, and the whole idea is to make sure that in the end you're creating content which is factual and you're avoiding hallucination, while making sure your LLM also has access to the most latest of the information. So that's pretty much about it in terms of my presentation. If there are any questions, I'm happy to answer those questions. Thank you.
Thank you so much, Salman, for your presentation. It was quite short, but very juicy and interesting. Uh, I don't see any questions right now, but I know that people are watching this recorded as well. So there may be questions later on the chat. I am connected with you on LinkedIn, so I will find you and let you know if there is something important that we
Yeah.
didn't discuss regarding your session. I want to thank you again for being here tonight with us. We are grateful that we can that we could have you, and yeah, we will stay connected, and hopefully we will see you in
Yeah.
another event of ours. Have a
Right.
great one,
Thank
my
you.
friend.
Thank
Bye
you,
bye.
everyone. Yeah, thanks. Bye.